is multi-stage Docker build and Docker compose. Explain why we need multi-stage Docker build and why multi-stage so important. And I will explain the concept of Docker compose, multi-stage Docker build. Multi-stage builds are a powerful Docker feature that allows us to use multiple from statements in a single Docker file to create optimized, minimal, and secure production images. This technique separates the build environment, which often requires large compilers and SDKs, from the final lean runtime environment. How this works? This has multiple stages. A single Docker file includes multiple from instructions, each beginning a new build stage. Naming stages. Stages can be named using as or as space name of it. For example, it would be from golang 1.22 alpine as builder for easier reference. So the golang 1.22 alpine would be referenced or will be given a short form, that is builder, as a reference. Selective copying. The key is the copy from stage name or the number instruction. This command copies only the necessary artifacts, like that is compiled binary or production ready files, from an earlier stage into the later, typically much smaller stage. Final image. The resulting image is solely based on the last stage defined in the Docker file, discarding all the intermediate stages and their unnecessary build tools and dependencies. That was about multi-stage Docker build, its definition, how this works. Now I'll explain in a simple example how this works. We must know that the purpose of a Docker file is to containerize the application. So when that image is built and run, so it creates a container, and that container is the app in itself. If we create a Docker file, only one stage that has build and runtime, that would be a really heavy process, or that take up a lot of space in an application to run. We need build features or binaries that are really important. I get it, but we only need that for a runtime environment, not throughout the process. So multi-stage Docker build separates that each stage. So the first stage gives us the artifacts or the gold, and the second stage, that is a runtime, that extracts that gold. So it only takes that information as a gold to create a runtime environment. So that runtime environment is stage that is taken as the final stage, so the image is lightweight. Another example, imagine you want to have exotic food and you don't know how to cook. So you hired a cook to give you that food. So he said like, yeah, I can cook and give you that food and prepare that food for you. So he said like, I would charge 500 rupees for cooking that food. So you said like, yeah, that's reasonable. However, you thought like, I don't want to go and buy the groceries, the spices, the vegetables, and each ingredient in it. So you don't have anything in your kitchen. So you said like, yeah, you are cooking for 5,000, but I also want you to go and bring each ingredient from the grocery store and also try to negotiate the prices, etc. All this headache should be managed by you. So you first bring those ingredients which I don't have in my kitchen, then you start to prepare the food, and you expect like he would say, yeah, I would do that for free, I would only charge for the cooking. But it is not the case. He said, no, I would not be doing it. I said I would only cook the food. So if you want me to bring all those ingredients from the grocery store and negotiate to its prices as well, and then cook the food, I would charge 50,000 from bringing those ingredients. and only 5,000 for cooking it. So you are like cooking it's less costly than bringing those ingredients, but you only want to have food. Analyze the example. I just exaggerated the cost so you can have the understanding of it. So this is the case with multi-stage Docker builds. So if it was a single process, it would be like the chef would bring all those ingredients, then start to cook the food, and he would charge you 55,000 rupees. And you say like, yeah, I'm okay with it, I will pay for it. So in our Dockerfile example, you would be utilizing a lot of storage, which is similar to 55,000 rupees. So if the situation was different and it is multi-stage Docker build, so the situation that would happen would be the chef would do the usual step of negotiating and bringing each ingredient into your kitchen and then start to cook the food. That's the same. However, when the chef enters the kitchen, magically he forgets that he has to charge you extra 50,000 for bringing those ingredients. He just charges you for cooking the food. So the magic that is happening is the separation of two steps in a multi-stage Docker build. So in that separation, we only take the result, that is the ingredients which we get from the stage 1, and we utilize those ingredients and cook the food, which would be like the runtime environment of the second stage, and we build the image from that final stage. So here's the example, that is Go application. This is a common use case with compilation language like Go or Java, where the compiler is not needed at runtime. So the first stage is building the application with the full SDKs and binaries. From Golang 1.22 Alpine, this is the lightweight Alpine Linux with Go SDK. So we're extracting that Alpine image and we are giving it a reference as builder. So second line is WORKDIR, that is the working directory, that is /app. We want to have a separate directory, that is /app. Third is copy go.mod space go.sum space ./ That means copying the dependency files first so Docker can cache the dependencies. Copy ... that copies the rest of the source code. Then that is run command. CGO enabled equals to 0. That means disabled C bindings, making the binary full static. GOOS is equals to Linux. This ensures that the binary is built for Linux. Go build space -o /app/server space ./cmd/server. That means that compiles the Go application into a single binary called server. So this stage is a heavy stage where you are using the dependencies, SDKs, same as getting all those ingredients and compiling it into a server. Stage 2, creating a minimal runtime image from scratch. Scratch, that is an empty image, no operating system, no libraries. Working directory space /app. So /app is the working directory. Copy from equals builder space /app/server dot. This is the most important step. That's where the magic happens. So it says it only copies the compiled binary from the stage 1. Simply, we are only taking the ingredients we got from the negotiations, from going to the shopping, going to the grocery store. We are only taking the ingredients we got from the stage 1, and we are discarding all those heavy work or the hard work we have done to get those ingredients. So we are only taking those results from the stage 1, that in short is called the compiled binary from the stage 1. So we are only copying those, and then expose 8080. Application will run on port 8080. Entry point /app/server. This defines the binary as the container's main process. So if we only had one from statement Everything that is Go SDK, build tools, source code, dependencies, compiled library or compiled binary would live together in the final stage. That means the container would be big and heavy because it carries all the build time baggage, even though we only need the final binary at the runtime. With multi-stage builds, we isolate the heavy build environment from the stage 1 from the runtime environment that is light, stage 2. So stage 1 would be using a full Go SDK image to compile a binary. Stage 2 would be starting fresh, here that is scratch, and copy only the compiled binary from the stage 1. The result would be the final image that is lightweight, that is just your binary plus maybe a few metadata layers. All the heaviness of the compilers, libraries and caches is discarded because Docker only keeps the last stage as the runtime image. So you can fit in the example which I gave about the chef and ingredients, which exactly matches this entire process as a reference. Make sure to like, share and subscribe because of this simple explanation. Sorry for the plugin, whatever. So yeah, next is the benefits of multi-stage builds. Smaller image sizes significantly reduces the final image size by leaving behind build time dependencies, leading to faster transfer and deployment times. Enhance security. A smaller image has reduced attack surface because it only contains fewer package and tools that could have vulnerabilities. Simplified Docker files. It consolidates the entire build process into a single Docker file, eliminating the need for separate build scripts or multiple Docker files, for example, one for development and one for production. Improved caching. Docker can cache immediate layers more efficiently, speeding up the subsequent builds, especially when the source code changes frequently but dependencies do not. So that was about multi-stage Docker build. Now let's understand what is Docker Compose. Docker Compose is a tool for defining and running multiple container Docker applications using a single YAML configuration file, typically named compose.yaml. This simplifies the management of application stacks like a web service and a database that requires multiple containers to run and communicate with each other. So let's take the same example of our chef and our exotic dish. We needed the exotic dish as a result, or we want that dish for us to eat. But to specify that dish includes a mojito, a dessert, a salad, and the main course. That is, in short, the food that you want. So the chef said, I will bring those to you after cooking. But the catch is, he said that he will only bring each one after the other, bringing you one juice first in your table. Then after that, he would go and then bring the salad. He will go and then he will bring the main course of the meal. He will go again and bring the dessert. So in that example, it's only limited to taking time to go and bring those food that you ordered. But in reality, that would mean you have multiple containers that are running. That is a separate container for web services, that is like a front end, and also for the backend database. So you have at least two containers that are running. Instead of running each container one by one and then utilizing your application, or in our example, getting each ingredient one by one and then having a meal, or using Docker Compose, that is like saying the chef to bring all those food in a single tray. So it would be like he would be bringing salad, main course, the juice and a dessert at one time. So it's similar to that. In Docker Compose, we create a YAML file, that is compose.yaml, that simplifies the container process into running a single compose file, which means you don't need to run each container. You only need to create a YAML file, specify the information in it, and then run the compose.yaml. So after running those compose.yaml, your both containers would communicate with each other and run at the same time, and your application would be running. In short, to run multiple containers that communicates with each other, so instead of running each container one by one and providing the result, so we skip all those hard work and we create a compose.yaml, that is docker compose.yaml, and we specify some steps in it. After we run that one compose.yaml, that would result in running all the containers, at least the two I specified, that is like the web service and a database, at the same time, that communicates with each other, that serves the application. Key concepts in Docker Compose. Declarative configuration. Instead of using multiple complex Docker run commands, you define all your services, networks, and volumes in one file. This file acts as a blueprint, ensuring consistency across different environments: development, testing, production. Service definition. The service section in the compose file defines each container that makes up our application. We can specify image to use or a Docker file to build from. Exposed ports, volumes, and environment variables. Single command execution. A single command, docker compose up build, which builds and starts. Docker compose creates and starts all the defined services and their dependencies. Networking. By default, compose creates a single network for your application, allowing containers to communicate with each other using their service names. So Docker Compose simplifies the process, so we don't need to use complex Docker run commands. Instead, we define all our services, networks, and volumes in one file. So that file, Docker Compose file, acts as a blueprint that ensures consistency across different environments. That compose file has service definition. In that service section, the compose file, we specify the image to use. The ports, volumes, and environment variables all are defined in the service section. And it's a single command execution. For networking, Docker Compose creates a single network that allows containers to communicate with each other using the service names. In my next video, I will be showing you Docker Compose as well as the Docker file or multi-stage of my own application that I built, so you can have better understanding of this concept. Common commands for Docker Compose. Docker Compose provides commands for managing the full life cycle of our application stack. Docker Compose up builds, if necessary, creates, starts, and attaches to the container for a service. Uses the D flag to run in the background or in the detached mode. Docker Compose down. This stops and removes containers, networks, and if specified with volumes, the volumes created by it. So it stops. Docker Compose PS. This lists all the containers in the current project, showing the state and port mappings. Docker Compose logs. This allows us to view the logs as an output from containers. Docker Compose up build. This builds the images for our services. In short, Docker Compose allows or multiple containers that are created. Instead of running each container one by one, and or at least starting each container one by one and then run our application, we specify certain information in the service section that includes environment variables, ports in it to run all containers at the same time that communicates with each other. So that is it for the video today. I hope the topic was simple and insightful. Make sure to like, share, and subscribe. Thanks. Have a great day. Bye.